The first paragraph here doesn't contain anything important mathematically. It just talks a little bit about Olympic ski jumpers. So we can ignore that. A skier begins his descent at point B, which we can see on the graph here. Accelerating down the ramp, at the end of the ramp, the skier is traveling horizontally at point E at 32 meters per second. So we start measuring time there. T is equal to 0. Note that X is equal to 100 and V is equal to 32. So T is the number of seconds in flight after that point, which we've already sort of acknowledged here. H is the height of the skier above the horizontal ground, which is basically the x-axis, and X is the horizontal position of the skier at time t. The slope ground, which we can see just here, is given by y is 170 take away 0.5x. The ski jumper's suit and skis decrease the horizontal velocity so that x dashed, which remember is v, is 32 e to the negative 0.05t. We want to show that x of t is equal to this. So we're starting with x dashed is 32e to the negative 0.05t, and then we're going to integrate. So we know that that's going to be 32e to the negative 0.05t divided by negative 0.05. I think I've already got 32 divided by 0.05 on the calculator. I have it 640. So that's negative 640. Of course, there's a constant here as well. E to the negative 0.05t plus some constant. We know that x is equal to 100 when t equals 0. So 100 is equal to negative 640 plus c, and that obviously means that c is equal to 740. Therefore, x of t is 740 minus 640 e to the negative 0.05t as required. It is found that the expression for the position vector of the skier during the flight is given by this vector here. Calculate the height of the skier above the sloped ground after 3 seconds of flight, correct to the nearest 0.01. Well, h of 3 is what we get from here. Remember, that's the height above the horizontal ground. So it's going to be 120 take away 2.5 times 3 squared. So 120 take away 2.5 times 9 is 97.5. Now, the equation for the slope was 170 take away 0.5x. So we also need to know x of 3, which is going to be 740 take away 640 e to the negative 0.05 times 3, which I've calculated as 189.146 and so on. Therefore, the y of 3 is going to be 170 take away 0.5 times 189.146 and so on. So we have 170 take away 0.5 times my last answer, which is 75.426 and so on. And so it's going to be the height above the slope is going to be the height above the ground. Take away the height of the slope above the ground, giving us 22.07 meters. So above slope is going to be 22.07 meters. For us to determine the vertical lift provided by the skier's suit and equipment in the descent, if d2h dt squared is equal to s minus 9.8, where s is a constant. Well, we know that h is 120, take away 2.5 t squared. That means dh dt is negative 5t. And therefore d2h dt squared is negative 5. So s take away 9.8 is equal to negative 5, giving us that s is equal to 4.8, and that would of course be in meters per second squared. It can be shown that the Cartesian equation for the skier's flight is given by this expression here. Calculate the time taken for the skier to land on the sloped ground correct to the nearest 0.01 seconds. Well, that must be when the path intersects the slope. In other words, here we've got the path, and where it's equal to the slope, which is the 170 take away 0.5x. Okay, so I've solved that on the CAS. I've got x equals 100, which is of course e, the takeoff point, and we've also got that x is equal to 255.915 and so on. Now, we know that x is 740. Take away 640 e to the negative 0.05 t. So if we put that equal to 255.915 and so on, we'll find the value of t. And I've solved that as well, which gives me that t is equal to 5.58 seconds, correct to the 2 decimal places required. We now want to calculate the angle at which the skier impacts the sloped ground, correct to the nearest 0.1 degrees. So if we think about the sloped ground here, we're going to come down and impact here. So we need to know the direction of motion of the skier. And then we're going to also need to consider the angle of the slope. So, if r of t is here, we know that r dashed of t is going to be, now we were already given the I component of that earlier on, so it's 32 e to the negative 0.05 t, and we've also established that we get negative 5t for this. So what we really want is r dashed of the 5.58 and so on. So we need to evaluate each of these expressions at 5.58. So we can see that this is 24.204 and this is negative 27.921. So in other words, 24.204 this way and 27.921 this way. So if we work out this angle here, let's call it theta. Theta is going to be the inverse tangent of 27.921 over 24.204. So, go for trig, and we're in radians. Degrees will probably be better here. So we want the inverse tangent, and we're going to use this value here divided by this value here. And that gives me 49.08 degrees. We also want the angle of the slope. The angle of the slope, of course, the gradient is 0.5. So it's just going to be the inverse tan of 0.5. So inverse tan of 0.5 is 26.57. And the angle that we want, so our final angle, is going to be this angle, take away the angle of the slope, giving us 22.5 degrees, correct to the 1 decimal place required.